Thank you, Nate, for the introduction. Hi, everybody. I'm Monica Kenguva, software engineer from SPDK team at Intel. Today, I will be demonstrating how to deploy SPDK container storage interface on multi-node Kubernetes cluster. You can refer to the design document as well as the steps that I will be following through this demo on SPDK CSI GitHub repository. I would like to take this opportunity to acknowledge Rebo Kai and his team for their work and contribution to SPDK CSI project. Today, we will be briefly looking at the CSI architecture and volume management APIs and use them in this demo. Kubernetes cluster for this demo contains 3 nodes. Nodes can be virtual machines or physical platforms. We have 1 primary node and 2 secondary nodes. There is 1 dedicated storage node with NVMe devices running SPDK stack over it. The SPDK storage node accesses and communicates with the secondary nodes with NVMe-oF fabrics. Pods are the smallest deployable units of computing that you can create and manage them in Kubernetes. The CSI controller pod provisions volumes and issues RPCs to SPDK storage node and access them through NVMe-oF fabrics. CSI driver node is responsible for connecting to SPDK over NVMe fabrics and exports them to remote volume as local block devices and mounts them to the pod. The CSI node driver node should run on each Kubernetes node as it must access local device and file system. The storage node, which runs the SPDK stack, exports the storage services through high-speed data network NVMe-oF fabrics and control interfaces through JSON RPCs. For more details on CSI internals and development, refer to Rebo Kai's talk in SDC 2020. I have provided this link at the end of my slides. Dynamic volume management. It is enabled by the use of storage classes. A storage class provides a way for the administrator to describe the classes of storage they offer. As you can see, the CSI workflow is majorly driven by these RPCs, which enable creation and deletion of storage volumes on demand. The CSI controller driver receives this create volume RPC, which provisions a persistent volume. Persistent volume is nothing but a piece of storage somewhere in the cluster that has been provisioned by the administrator manually or dynamically provisioned via storage classes. Persistent volume claim, PVC, is a request for storage by a user. PV and PVC are a way of matchmaking. Admin advertises what's available with PVs, and a developer or application makes request with the PVCs. So here, the controller publish volume RPC exposes the provision volume so that the node can access it. The node stage volume, which is received by the CSI node driver, connects to the export volume through network and mounts to staging path. Finally, the node publish volume, also received by the CSI node driver, binds mount staging path to the pod volume path. For this demo, we are going to prepare SPDK NVMe over TCP target on storage node. Then the CSI controller driver creates LVOL and NVMe over fabric subsystem. The node driver connects to the subsystem and mounts the volume to the local host in the pod. Then we launch a test pod with PVC referring to SPDK storage class, which triggers SPDK persistent volume creation and mounts to the pod. Let's proceed to the demo to go through the steps of SPDK CSI deployment now. kubectl get nodes gives the current snapshot of the Kubernetes cluster. As you can see, Kubernetes primary node and 2 secondary nodes are running in ready status. Now let's prepare the SPDK node to create NVMe bdev and LVOL. In order to issue SPDK JSON RPCs, such as bdev NVMe attach controller to create NVMe, we need to start the SPDK target. Once we have that, we can issue the JSON RPC. NVMe E0 and 1 has been established. And now we could also start the JSON RPC for the to enable remote access to the SPDK storage node. As you can see, SPDK RPC HTTP proxy server has been started. Proceeding to the primary cluster, primary node, I have built SPDK CSI image on both Kubernetes secondary nodes where the CSI controller and node drivers will be scheduled. Also, the SPDK storage pool configuration need to be passed to the SPDK CSI driver in deployment YAML files. Let's look at some of the YAML files in order to confirm that. The config map YAML file contains the IP address of the SPDK storage node. The secret YAML file contains the credentials of the SPDK storage node. Now, we will deploy the SPDK CSI controller pod as stateful set with replica 1 to make sure only one instance is active in the cluster. And also, we deploy SPDK CSI node pod as a daemon set only so that only one instance on each worker node runs. Now let's deploy both of them with the help of the deploy script. And with the help of all the YAML files, we can see that the SPDK CSI controller and node driver should be running now. In order to check that, we will be using kubectl get pods to get that information. As you can see, the SPDK CSI controller and the node drivers are in the running state. Now we will deploy the test pod in order to request some block storage from the SPDK CSI driver and mount them to the SPDK wall directory. Here, the storage class name is SPDK CSI SE, and the same is used in the SPDK persistent volume claim. Now let's go ahead and apply this particular YAML file. SPDK CSI PVC is created and the pod is created as well. In order to check the status of the same SPDK CSI test pod, we will be seeing that it is running in the running state with this particular IP address and on node 1. We can also check the mounting information. Kubernetes provides various information in terms of logs. So we can use kubectl logs for this SPDK CSI controller in order to use for any debugging information. As you can see, we are using volume created and volume published on the particular SPDK target node in order to publish the volume. As you can see now, we have the SPDK CSI test running as part of the various pods. So we have currently 4 pods up and running. The same information of kubectl get pods can also be available on the Kubernetes dashboard. Here we can see a snapshot of SPDK CSI test being run along with the other pods in the Kubernetes dashboard. So today we have briefly gone through the CSI driver architecture and deployment of SPDK CSI on multi-node Kubernetes cluster with dedicated storage node running SPDK with NVMe-oF fabrics. We launched a test pod with persistent volume claim referring to SPDK storage class. It triggered SPDK persistent volume creation and mounted to the pod. For further details on CSI internals, development, and validation, refer to Yubakai's video link here. For collaboration or questions on CSI, refer to SPDK Container Slack channel. Thank you.